Hello folks, thanks for joining. This is Arman Gangar with Metaspike, and this is a live forensic email collector workshop. Today we will discuss some of the recent developments in forensic email collector, what we've been working on for what's next, some email forensics best practices, and take some questions from you guys as well. So I will kick off with trusted timestamping. This is something that we've been wanting to include in forensic email collector for a while now. And I will discuss briefly what it is and how we integrate it into forensic email collector and what it can do for you in your email forensics work. So let's start by covering trusted timestamps and trusted timestamping and what it can do. Trusted timestamping essentially is using a centralized authority to get a definitive timestamp on a certain data point. So that proves that you had that data point before a certain point in time. Well, how does that work? So essentially what you do is you create a hash of your data, whether it be a file or some type of file fragment or text, and you compose a timestamping request, which includes your hashing algorithm of choice and the hash of your data point, and you pick a trusted timestamping authority, essentially a server that runs a timestamp server software with specialized hardware, and you pass that timestamp request to the server. The server creates a digitally signed packet, which is a timestamp response, and in the response it includes, depending on your preferences, it might include its certificates. It includes a timestamp. It includes the hash of the original document that you had passed in your request, and a few other things, and transmits that packet back to you, which serves as an immutable record that data point existed at that time because you made the transaction at that time. So you must have had access to either the data or the hash of it. So it existed at that point in time. How does that help us? Well, in forensics, a lot of times we work on very time-sensitive matters, and sometimes it's desirable to kind of set that in stone and show that you had that data point and you couldn't have changed it, or nobody else could have changed it subsequently. So, for example, you might think of a website collection. You collected a website and you want to show that that's exactly how the website looked exactly at that time. So you do your preservation, you pass that the hash of your acquired data to the timestamping authority. They timestamp it for you, and you have a record of what that hash was, that the hash of the data that you collected at that time. Now this goes beyond just website collections, of course. So this same thing applies to email collections as well. So you might have collected emails, and some of the email data that you collected might be easy to authenticate and definitively show the timing of by itself, and some of it might need an external entity to attest to its timestamp, things like logs, for example, or mailbox rules, things of that nature that don't have have an inherent timestamp within themselves. So let's take a look at a few examples. I'll show you what the process looks like, what the timestamp request and responses look like, and how we can accomplish this both with forensic email collector and outside with other tools. So let me share my screen with you here, and let's go through a few things here. So let's say that you did an email collection and you ended up with an email message itself. So the email message might look something like this. Let's open this up. So you have your email message itself, you have its MIME contents here, and obviously the email message has a date on its face, the sent date, the origination date. And you could authenticate this email message, check for its DKIM and ARC signatures, see that it's DKIM signed by Yahoo, and that covers the date header field, the origination date, and you know what that date is. So if DKIM checks out, then that date could not have been changed subsequently by the end user. And you look at all the other timestamps in there, so you authenticate the message. And that could serve as your timing data point, essentially, because this is kind of self-contained. And in effect, an email message itself could serve to timestamp a different data point. So you could have a contract, for example, and you could email that contract to somebody else, and on the receiving end, if that message was DKIM signed through a trusted third-party provider like Gmail, then that could watch for its timestamp. But on the other hand, you might work with some other data points that are not like that. For example, let's look at this mailbox rules that we capture along with an acquisition. And this file itself, although it captures the state of the filters within Gmail at a certain point in time, it doesn't have its own timestamp that could easily be authenticated outside of what you see in the file system. And the file system timestamps you see there, both in the file's name and its file system metadata, they are correlated with the timing kept by the local computer where the acquisition took place. So if the computer didn't keep accurate time, then you don't get accurate timestamps there. So that's the reason for trusted timestamping. Just about any forensic tool that you would use that keeps track of time and logs things relies on local timestamps from the computer where it's running. Whereas if you want authoritative timestamps, you would want to get a third-party server that specializes in that to confirm that for you. Same thing with this, for example, this downloaded items log. Let's say that we acquired this log and we want to show that certain UID gaps were seen on the server at a certain point in time. Again, there are some timestamps here, but that doesn't show us conclusively when this acquisition took place and when we observed that issue on the server. So how would we go about tackling this? Well, we could do our acquisition and then have our output or our logs timestamped. So let's walk through what the timestamping request and response look like. So to get a timestamp, essentially we form a request first, and the request, like I said, contains the hash of our file and our hash algorithm and a couple of other flags. For example, do we want the server to get back to us with the certificates that it used or referenced. But once we pass our request to the timestamping server, the server gets back to us with a timestamp response, and part of it is this timestamp token, which is essentially a signed data construct. And this is a package that looks along these lines. There's some detail here, the cryptographic message syntax version, the digest algorithms that are used. You could actually get the documentation on this here. Let me drag a browser window here. So RFC 2630 defines that signed data type, and you can kind of walk through it and see what each of these items mean, like the version and the digest algorithms and the encapsulated content info. But in summary, we're mostly interested in the certificates here, which are it's controlled by the request that we sent to the server. And if we requested the certificates, then they will be included in the response, which we'll use in authenticating. And then the encapsulated content info is actually the type and the actual content, which is our TST info, the timestamping that we're looking for. So that looks something like this. The TST info has a few fields. Again, the version, the timestamping policy that was used. The message imprint is the hash of our message, essentially. So we sent that hash in the request and we get it back in the response, and those two things should match. There's a serial number for the timestamp that the server produced. There is a generalized time data point, which is the actual timestamp itself. Accuracy, which tells us how accurate the server believes its timestamps are. There's an ordering flag, which determines if the timestamps are ordered, as in could we assume that the timestamps came out of the server in a certain sequence, even if the timestamps themselves are not accurate? The nonce is something that we pass in our request, and it's a large random number. That's something that the requester creates uniquely for each request. And then on the way back, we check that is the same value against replay attacks, essentially. And then there's information about who signed the TSA and all that. So let's do a quick example of this in how this looks like in Forensic Email Collector first. So let's start by setting things up, and we have a document on setup here, but the important part is we have included a few timestamping authority URLs here that you could possibly use, and there's a lot more here on this website. So you can check those out there, or use any service that you already have or that you're using. Some of these are free services and some of them require a subscription. But the key here is this: the timestamping RFC relies on a centralized method workflow, essentially. So you're relying on a centralized server and its authority. So it's important that this authority is a trusted third party, and you have no control over it. So in other words, if you work with a fly-by-night operation that's not reliable, then that doesn't do much in the way of authenticating your items. And same thing, if you are running your own timestamping server, for example, then that doesn't lend much credibility to the timestamp that you create. You want to use a third party that you don't control. So you can pick from any one of these. For this first example, I'm actually going to grab this global sign timestamp authority, and that goes here in the TSA URL in FEC's preferences. And once you put it in, you can actually run a quick validation to see if timestamping works with this URL. So if you're finding some URLs and you're not sure if that is a running timestamping server, you can check that here. And then I will import a quick authentication token here that I have, and add my target. Skip over these steps. Let's pick an output folder here. And here I'll check timestamp logs to timestamp my logs, and I will run a quick in-place query to narrow down the data set that's on the server. So I'll just include a single search term that should have some results. And that'll result in our acquisition, and done. So let's take a look at what we got. So in addition to what we typically get with our acquisition, which is going to be the logs and the items and the FEC project file, we get 3 extra files. One of them is a zip file in this case, which is a package that contains everything that was in the logs folder at the time that the acquisition finished. Now, if you do multiple takes, like you ran your acquisition to completion and it finished, and then you reopen that acquisition project, you reran it for some reason, then you will get a second package with the state of the logs at that time. So you could have multiple sets of those, but normally you would have only one. This is the timestamp request that we form and send to the timestamping server, and this is the response that we got back. Now, how do we validate this? Because you would want to check that you got your timestamps, but before you go any further, it makes sense to confirm that this is working. So you could do it a couple of ways. You could do it within FEC, for example. For that, you would go to this verify trusted timestamp page and drag your 3 items and drop them over here. And it says verification results verified. Here's the path that we checked, the calculated hash. This essentially matches the hash of our file here, the SHA-256 hash. The timestamp, so this is the trusted timestamp that the timestamp server sent us. This is the TSA that was used. And here's some information about the certificate chain. So verifying this involves a few steps. Number 1, we look at the request and the response together to make sure they match. For example, the nonce in the request matches the nonce in the response. Same hashing algorithm is used. The response actually belongs to the file that we're verifying here. Otherwise, it's not really worth anything. And then we look at the certificate chain in the response to make sure that the chain is something that we trust. So there's going to be a chain of certificates that go all the way back to a certificate authority or a root. And we want to make sure that we trust that chain. In this case, we trust that chain automatically because Microsoft's machine certificate store already has global sign certificate root in the store. So when we drag this over and verify, we don't need any extra certificates to trust that the chain is valid. So we're good. So let's do a scenario where the chain is not inherently trusted. So I'm going to use another certificate authority here, which is this one, freetsa.org. So let's configure FEC to use FreeTSA instead. So we'll go here to the same area, put FreeTSA as our timestamp authority, validate, go back and let's do the same authentication token workflow here. Timestamp our logs. And let's run the same query. All done. All right, so we got our logs again and our trusted timestamp. So if I drag this over, these three guys, now the verification results say false, it's not verified. And if you look, the hashes match, everything looks good, we got the timestamp, but at the bottom we have a message that says certificate chain processed but terminated in a root certificate which is not trusted by the trust provider. So in this case the issue is this, FreeTSA is using a certificate root that is not trusted on this Windows computer. Now one of the ways to work around this is to find that certificate root and add that to our machine's certificate store as a trusted certificate, but I don't think that's necessary because that's not really the solution, and also we want the certificate to be able to be verified by just about any third party like another expert that you produce this to, for example. So the solution to verifying the certificate in this case is to go get the certificate authority certificate for this timestamp provider. So they provide it right here in a convenient place. So we can save this here. Let's go find our acquisition and drop this here. All right, yeah, the name of that doesn't really matter. So let's try to do this two different ways, once with FEC and once with another tool. So I'm going to use FEC first, drag these 4 items, and now verification results check out. So now that we added the certificate authority certificate to the chain, then we're essentially saying, hey, I know that the chain is missing something, and here's the missing piece, and I trust this. And in this case, I trust it because I trust this provider, for instance, and I got it from their own website, so I know that that is a legit certificate. So my chain is complete, and the message here is that the chain is not trusted on this device, but it matches the supplied certificate. So we are adding that missing piece to the puzzle, and we're good. Now let's take a look at how we would verify this outside of forensic email collector, because we may not necessarily want to go that route. So I'm going to use OpenSSL in the Windows subsystem for Linux here. So let's open a command prompt for that. All right. So let's go to I think is where we were. see what we have here. So we have the the logs and the certificate authority time cert here. So I'm going to use, first I want to look at the timestamp response here before I get into verifying it. I'm going to say OpenSSL TS apply and I'm going to load in my logs .tsr and text. So with OpenSSL, I'm able to see that the certificate, the timestamp is granted, and version 1 is expected. SHA-256 was used. Message data should be my hash. So let me compare that to what I have here. If you see the hex here, so it starts with 4C and ends with that 1C here. So if you notice here, for example, when I'm running OpenSSL and looking at the certificate, OpenSSL is not taken in as a parameter of my original file. So my timestamp might be good, but if the message digest doesn't match my original file, then this is worthless. So that's the first thing we need to check to make sure that the message digest here actually matches the message digest we started off with. Otherwise, this could be a random timestamp that belongs to whatever. So that's very important when you're doing this manually. FEC does this on the back end. If you do it manually, you would have to do that extra check. Serial number for the certificate, the actual timestamp, no accuracy specified. Ordering, yes. The NOS is what we had sent, came back, and some information about the TSA. So now let's try to verify this. So we looked at its contents now, but we haven't told OpenSSL to verify. So we're going to do something similar. We'll say verify .tsr. This time it's also going to ask for the query file. So this is the original timestamp request that we had formed, and the reason for this is it needs to compare the query to the response to be able to say the query and the response are compatible. But here when we run this, as expected, we get this a similar issue. It says verify error, unable to get local issuer certificate. So the issue here again is that the certificate chain is not complete. So the way to remedy that in OpenSSL is to add a switch CA file and add the certificate authorities, add the TSA's certificate authority certificate here. In that case verification is okay. But again, as you see, this whole verification process did not enroll my original file. So as far as OpenSSL is concerned, this file is not even there. We didn't input that file into the process. So that's something that you have to do separately if you're using OpenSSL, and make sure that your file matches, the hash of your file matches the hash in your response. Now a couple of things to consider here. So one of them is the hash. So you might have heard in the past, for example, that MD5 is broken, it's not very useful. And when you think about it in the context of de-duplication, for example, for rediscovery, yeah, maybe when you're just looking at a bunch of files and trying to find duplicates in them, and there is no motivation to really create such duplication, then MD5 might still be okay, although I wouldn't use it. But in a process like this, it is not okay, because here's a process where you're trying to confirm the timestamp of a file, and if there is motivation to create a different version of that file or an entirely different file and make its hash match the hash that was in your original file to make it look like that was the file that was timestamped, then the security of the hash becomes very, very important. So in that case, probably MD5 and SHA-1 are out of the picture, and you want to jump into SHA-2 here and do SHA-256 or SHA-512, depending on what your TSA supports, to use a strong hash so that the file could not be altered and its hash matched to the original. So that's an important point. And then you have a long list of providers you can use. Like I said, we have included some of these in our documentation. There are also some paid providers. For example, I'll show you one here. One of them is Digistamp. And if you work with a provider like this, so this is something that requires a username and password, and you pay them to provide the service for you. But if you look at this, for example, they supply their public key certificates nicely here. So they have a full record of historical certificates as well as what's current in multiple different protocols. So you get essentially what you need to be able to decode that timestamp response, not decode, but verify the chain later on. Well, if you're not using something like that, then at a minimum, I would say when you do your acquisition, whether it be an email acquisition or anything else that you use a trusted timestamp for, you should definitely include your certificate, the root certificate, as part of your data collection, because you never know later on that chain may not verify, and if you're missing that piece, that could come back to bite you. So it should be included in your data set, and that's something that you get from the provider separately. Again, free TSA is designed for that as well, so they provide that to you in a nicely accessible page, whereas some other providers that we listed here, it might be more challenging to find their root certificates in some cases. So let's move on to the next item we have on in our agenda. One thing I wanted to show you here is that after we created this timestamping capability in FEC, we also created a best practices document. I recommend that you check this out, especially if you do a lot of email preservation work, whether it be with forensic email collector or otherwise. And you might find some interesting things about how we recommend setting up your environment, how you prepare for an acquisition, what are your options for authentication and what you should choose. If you're doing modern authentication, what are some of the things to watch out for? Do you want to capture your network traffic? Do you want to do trusted timestamping? Where do you output, and how do you do quality control when your acquisition is complete? So we've created a few things like that should help you with email forensics best practices. Now, if you do this a lot and if you have your own best practices that you would like to share, feel free to reach out to me. I would love to hear it. If you missed some things, we would like to add that here. Or if you found this helpful, definitely let me know. And we will be happy to chat about it or discuss further. Now, the next thing I want to move on to is something that we added recently, again, after the last workshop we had, and that is using custom authentication tokens. So if you're using FEC, you're probably familiar with the existing workflows we had around remote authenticator, and that allowed us to acquire emails from an end user without knowing their password, and they could share a token with us, and we could import that and use that for acquisition. And in the law enforcement context, there's different capabilities around leveraging existing login sessions from a suspect's web browser, for example, or a web browser in a suspect's workstation's forensic image, or a web browser in a suspect's cell phone to create an authentication token and go from there. So those were the existing workflows we already had. But since the last workshop we had, we also added the ability to use custom tokens from other sources. So I'll show you a couple of things about that, just to get your gears turning. It may not be applicable in most civil cases, I would imagine, but in the law enforcement context, it is quite useful. So let's look at a few things here. So that happens in this area here. So let's say that I'm going to target the same mailbox that I've been playing with earlier. And you know that we can import a token like I did earlier and go from there instead of authenticating directly. But there's another little menu here for importing a custom token. And that opens up this page. So here we have a few options. The target email, which is going to be the same as what I'm targeting right now, so no surprises there. An access token and a refresh token, and some scopes that that we can pick. Now, first, let's do a little background on what an access token and a refresh token is, just to refresh your memory. So these are concepts about modern authentication, OAuth workflow. And there are two tokens to speak of there. There's an access token, which, as far as we're concerned here, it's kind of like a free pass. So if you have the access token, then that is almost as good as a password. It just allows you to access that resource with the scopes and permissions that had been supplied when the access token was created. So in other words, if you have an access token for Gmail read-only access and the token is still live, then you can use that token to access Gmail in a read-only manner. Yeah, I'm getting a question about the cell phone option, so I'll circle back to that. Thank you. So the refresh token, well, let's backtrack for a second. So access token, like I said, is kind of like a free pass, but the downside of that is it's limited in time. So usually, for example, for Gmail, an access token lives for 3,600 seconds, so an hour. So that limits its usability. Now, refresh token is another token that may or may not have been supplied along with an access token, and that allows the requester to refresh the access token. So not really refresh, but essentially create a new access token on demand, providing longer term access. But refreshing the token requires that the requester use the API credentials that have been used to create the token in the first place. So it's not something that you can just do arbitrarily without the proper access. So having these in mind, let's look at a couple of examples. So I'm going to first grab a sample access token just to show you what that looks like, and just so you're familiar. All right, so an access token, for example, might look something like this, just to show you what for Gmail, what the length of it looks like, for example. And where might you get this? Well, you might get something like this from a mobile extraction, for example. I'm sure a lot of you are familiar. So let's say that you did a cell phone extraction from an end user's phone, and you got some authentication tokens. And it could be a civil case where you leverage this to access, for example, maybe a deceased person's data, that the person is no longer available and the password is lost, and you have legal authority to access the emails for maybe an estate matter. Or it might be a law enforcement action where you're doing a dawn raid, search and seizure, search warrant type thing, where you have access to some devices and you want to leverage them to get the data that you need, and you have legal authority to access. Now, that access token I just showed you was not a valid access token, but I have one just like it. So I'm going to show you what that would look like if you had something like this. So I have this target email. I'm going to put in my access token. I have Gmail access selected because my token is only read-only Gmail, so I couldn't do anything else with it. And then I will go back and charge ahead with my acquisition, and let's see if this gets us. And like I said, these have pretty short lifespan, but yeah, we're in. So if we wanted to do an acquisition from here, I could run an in-place search, like let's search for a label, for example, and kick off the acquisition, and done. So that access token that I got, and this wasn't a token for FEC, by the way, so it's just an access token. I was able to use an external tools access token that I got from somewhere, like a mobile extraction, like I said, and get it. But now let's backtrack for a second. So remember I said that these access tokens are only good for about an hour. So that really puts us in a bind sometimes. If you're in a law enforcement type scenario, for example, and if you have a suspect's phone and you want to leverage an access token there to gain access to their emails, and with legal authority, of course, then what you could do is the clock starts ticking when that token is last refreshed. So let's say that the access token belongs to an email app that the suspect was using. So you could launch that email app, causing the token to be refreshed, and then right away do a mobile extraction. Hopefully you can limit that to just the tokens, keychain, that kind of information, so that you don't have to wait for hours to do a full extraction. But get your extraction done, get your access token out of there, plug it into FEC, and do your email collection within the hour, hopefully with an in-place search. So that could give you just enough time to run an in-place search and get the information you need. Now, that may not be feasible in all cases, but it's an option in some cases. Now, the other option that I showed you was the possibility with an access token and a refresh token. So that provides, like I said, longer term access, but that's not going to happen all the time. For that to work, you need to have, so I'm going to go back here to import custom token. So imagine this time that I have not only an access token, but also a refresh token, which would allow me to refresh it. So I have my access token here, and I want to put in my refresh token, but I can't, because this is only available if you're using custom API credentials, and not just any custom API credentials, the custom API credentials for the tool that created those tokens. So you see that that's not always going to be something that's possible, but there might be some scenarios where that's the case. And in that case, you could essentially put the API credentials of that tool, whether it be a tool that was yours or a tool that you have access to somehow, and you get the API credentials for it. And then you can enter the refresh token, providing long-term access to FEC. So at this point, FEC could just take it from here as if it was an FEC token and do its acquisition. So let's try this here to make sure those tokens still work for me. Let's see if I can get in here. Yeah, so I'm in with the refresh token. In some cases, actually, you might be able to even skip the access token altogether, and FEC would refresh based on the refresh token if you have it. So this is something, like I said, this is not gonna come up all the time, especially for civil practitioners, but I wanted to bring it up just so you're aware of the possibilities, and especially for law enforcement, this is kind of key. Now, to go back to Yaniv's question there about a cell phone option, so that's something that one of our users actually discovered, and so I can't take credit for it, but in summary, how it works is that you use the debug bridge that's available, the remote debugging capability in Chrome. So what you do is you run Chrome on the examiner's workstation, and you plug the phone, that's your target's phone, through USB, and you use remote authenticator on the examiner's workstation to get a token back from the suspect's cell phone and control that Chrome. So there are a few steps there, but in summary, this works for both Android, Chrome, and also Safari with some setup. So if you have a case where something like that comes up, reach out to me and I'll kind of lay out for you what the steps are going to be, or we could do maybe like a little video walkthrough or something. But again, something just to keep in mind that it might be a possibility if it comes up. Not that it will come up very often. Now, the next thing I want to move on to is, again, something that we introduced after our last workshop, which was MIME Decryption. So this comes in handy if you have, if you're accessing a mailbox where you believe that a bunch of messages might have been encrypted, which is becoming increasingly popular. And what you do in that case, FEC has the capability to automatically decrypt those messages if supplied with the certificates that are needed, and you can do that a couple of different ways, and I'll show you what the output looks like, how you set this up, and some of the options you might have. So let's take a look at an example here. So let's fire up FEC again, and once again target the same mailbox that I've been hitting. Okay, so let's go through here. So here the option is decrypt as MIME. So I'm going to choose that option, and I have a couple of possibilities there. One of them is if you're running FEC on the computer where this end user was working, which may not be the case in the civil context very much, although it could be. And this is possible by using FEC in portable mode. So you could copy the whole tool onto a flash drive and set it in portable mode. We have documentation on this here for those of you interested. So let's say you're running FEC in portable mode and you are running on the computer where this email account was being used. In that case, you don't have to supply any certificates. FEC would connect to that computer's local certificate store and evaluate the certificates that it could possibly use, and it would cycle through them and it would use them to decrypt the messages as needed. So you're all set. And if it fails to do the decryption for whatever reason, like maybe the certificate was not found, then it would log those. So it'll be used that way. Now, if you're running this in your lab, so you're not on the workstation where this end user was, then you could add certificates. Let me see, I think I had an example certificate here. Yeah, for example, it might look something like this, like a PFX file. You are going to need a password for this. Let me see if I had that somewhere. Okay, so it says import certificate, and it says you can add more certificates if needed, and we've imported one so far. So why do we say that? Because we can stack these certificates. So we might need multiple certificates to decrypt different emails among different people. So you have the ability to load up as many as you have or as many as you need. But in any case, let's proceed with the acquisition. And let's run a search, I believe under the close particles label. I have an encrypted message. Alright, so the output for that looks like this. The main difference you'll notice is that there is now an encrypted MIME folder and a MIME folder. So this is where we store the original encrypted messages, if any. And the reason for that is for DKIM and ARC verification or for any type of authentication, you may want to have that original pristine copy before we did anything with it. So that's where this is. And you can look at this in this case. This doesn't have much to look at because it's the body of it is encrypted. So if you looked at this in a text editor, you would see there's a MIME part there. You probably have experienced this before. The name of it is going to be smime.p7m. So that's where the encrypted content is, and because we don't have the key right now, we can't decrypt that. But if you look at the contents of the MIME folder for the same message, this is actually the decrypted copy. So if you look at that, here's the body that was encrypted before, and this is the version that has been decrypted. Now, the reason we put the decrypted copy here is that we want this copy to go into all your other output formats. So if you selected, for example, in addition to MIME output PST format, then the decrypted copy is what goes in the PST. So if you're going to throw these into processing, you don't get those encrypted versions in your PSTs. You get the decrypted versions, which is most of the time what you would want, I imagine. But you have the encrypted ones to fall back on here. There's a question here about saving all of the certificates between sessions. So I'm imagining this as in, we created the acquisition project and then we do some retries and maybe we close and we go back and we resume. Can we save the certificates for future use? Yes, we can include them. So the certificates don't really sit outside in the file system. We kind of incorporate them into the acquisition project and we can reuse them that way, and they are saved for future sessions in your acquisition project. Okay, so there's let's see here. That's what we have for SMIME. Again, something to keep in mind for future reference. Now, a couple of additional things I want to show you. One of them is Drive. So let's have a little chat here about Drive. So one of the things that is happening right now, some of you got wind of this, and I've had a few inquiries about this already. Google is now rolling out a change to Drive security that involves how shared Drive attachments are accessed. This started rolling out on September 13th. But the summary of it is that they're saying that for a subset of Drive attachments, an additional data point called a resource key is going to be needed to be able to access the files. And if you don't have that as a security measure, the file is going to be inaccessible. Now, we have updated FEC already to capture that data point and supply it as needed. So we are pretty much ready to go, but that change is rolling out gradually. And even then, they're saying that it's the data point will maybe be required. So there's a little bit of lack of guidance there, I feel, and it's not exactly clear how it'll affect things. So we haven't had enough data to test it with. So we're kind of waiting on that to make a new FEC version to introduce that capability. So stay tuned for that. That should be coming as soon as we can test it with some real life data. Right now we have the solution in place, but it's hard to verify that it works. But as far as the impact goes, this actually should, from my understanding of Google's description, this should impact a pretty narrow slice of Drive data, because they say, if I'm understanding correctly, that it doesn't impact the user's own files. So let's say that you're running an FEC acquisition and you're acquiring John's mailbox, and any of John's own Drive files that are referenced there are not affected by this update. They're his files anyway, so you're good there. This only affects the files that have been shared with John from the outside. So somebody else sent him a file, and in addition to that, the file must have been sent with permissions not specifically for John, but broad permissions that allow access to anyone, like a public share URL. And in addition to that, John must not have accessed the file before. So let's say the file was accessed even with those public permissions, and back in 2018, and John accessed it a few times subsequently, then you're still good. But if all of those other conditions are met, then maybe a resource key will be needed to access that file. So that's something that you should have on your radar as far as Drive goes, and keep an eye out for. We are, and as soon as we can test, we will roll out an update to cover that. Like I said, the plumbing is there. We're just down to testing. Now, going back to our agenda here, one more thing that I wanted to show you is search cap detection. This is something we've added to FEC a little bit ago. And first, let's talk about this. So what is search cap detection? Well, one of the features of FEC is its ability to run in-place searches on the server. So when you run a search on the server, then the search is executed by the server, so you're subject to the search capabilities of the server. And some are great, some are not so great. But one thing that we've discovered is that in some rare cases, servers actually might put a cap on in-place searches, and they don't really tell you. So we have, for example, I'll show you an example of that. So look at this article, for example, that involves an Exchange server, and because of a bug or something that could be fixed with a patch later on, the search results on an Exchange server 2013 were limited to 250 items per folder. Now there's an update that fixes this and requires some configuration change, and this is for on-premises Exchange, so not for Office 365. But imagine that you are running an in-place search on an Exchange server. You think everything is great, but the server capped your search results and you don't even know about it. So obviously we don't want that to happen. We want you to be notified of any kind of trouble ahead of time. So we devised a method for FEC to actually detect such short search caps. So if it runs into any scenario where things look suspicious, for example, like I said, we can't really tell this from the server because the server doesn't give you an error message like, hey, I capped your search results. But let's say that you run a search and you run a search across multiple folders, and the maximum amount of results that you got is 250 and you see that in more than one folder, then yeah, that is pretty suspect. So we are doing some thinking there essentially to flag those kinds of scenarios, and we input a disclaimer at the bottom of your acquisition log to point that out, like an important note: your search results here might have been capped. Again, I don't think this is something that you'll encounter very often. I certainly haven't, but it's something to keep in mind and watch out for that detail in FEC's acquisition log if you are using in-place searches. Let's see what's on my list here. One more item to talk about, and that is the new capabilities we have for Drive. A couple of things, and there have been some questions about this, so I wanted to bring some clarity there. So let me share a screen here and hit the same mailbox here. Let's import that token. Oh, go back a second. All right, so when we fetch Drive attachments, we have added a couple of new options since the last workshop we had. One of them is to include contents of Drive folders, and one of them is to collapse duplicates. So I'm going to explain these just to make sure that we are clear on what they mean. So the first thing is including the contents of the Drive folders. So what we mean by that is not that FEC will go back to Drive as a whole and target users' entire Drive and get all the folders or anything like that. But normally what FEC is doing without that option is it's scanning your acquired email messages and trying to find out if there are any Drive items that are shared in those messages, essentially cloud attachments of messages. And if there are any, it'll include them in the acquisition. But that also extends potentially to cloud folders. So somebody could not only share a Drive file, but they could share a Drive folder. So what do you do then? So this is what handles that scenario. So if you include this option, if you check this option, then FEC will scan for any Drive folders as well. If it finds a folder, then it'll scan the contents of that folder recursively until it gets to the bottom, and it'll find any files contained in the folder. And if it finds any folders contained in the folder, then it'll scan the contents of that and include all of that in your acquisition for that email message. Now, as you can imagine, this could be pretty comprehensive. So this is not an option to just check all the time as part of your standard operating procedure, because potentially a Drive folder could include hundreds or thousands of files and maybe a terabyte of data. So that could really significantly impact your acquisition capabilities or timing. But we figured that it's good to have the option, especially if you know what you're doing, and if you have an email message where you know that there's a folder and you really need to get the contents of that folder, then yeah, use that option by all means. And if you don't use the option, FEC will still, in its acquisition log, in the acquisition summary section, it'll list any folders that it encountered, and it'll say, hey, there were 3 folders, by the way, and because of your instructions, we didn't explore their contents. So you can still have that, and you can say, oh yeah, there were some folders, so let's go target those in a supplemental acquisition, perhaps. So you don't have to always check that Drive folders option, but keep in mind that it's there. The second option was the collapse duplicates option. So this is in our quest to improve Drive acquisition performance, because that's kind of a hot topic, and it's really hard to do because Gmail presumably is not too fond of people pulling a lot of data from Google Drive. They want to maintain the performance of their service for the rest of their users, so they will throttle pretty aggressively, which makes sense. So we're looking really hard at how can we improve the performance of Drive acquisitions. And in our research and testing, one thing that came up is to cut down on duplication. And you might think, hey, how many duplicate items are there going to be in a message? But this is not about the duplicates in a message. This is about duplicates in an entire acquisition project. So what we do is, if you choose this collapse duplicates option, then FEC will still scan all the messages, but it'll collapse the duplicate drive IDs into one. So let's say that the same drive file by identifier, unique identifier, is referenced 20 times throughout the mailbox in different places, in sent items folder, in the incoming inbox, within folders, for instance. It'll collapse them all into one. It'll acquire it once, but then it'll reuse it wherever it's needed. So your output is going to be still the same. So we will still output as if you didn't collapse duplicates. But in the back end, we will reduce that to one. And I feel that that has really improved performance quite a bit, because you may not expect it, but when you look at how much duplication there can be in a mailbox within the drive items, you see that there's often quite a bit. And not only are these for the drive items themselves, but also the revisions of the drive items. So let's say you have 20 items that have that are duplicates, and then there's the revisions of those 20 items that are also duplicates. So that could really get out of hand, and you could be acquiring hundreds or thousands of extra files that you really didn't have to. So that's the point of this option here, to collapse duplicates. I recommend that you keep it checked when you can, as it should introduce a performance boost to some extent. All right, well, that's the agenda I have today, and I see that we are just about at the 1 hour mark, so I want to leave a couple of minutes for questions if you have any. You can use the chat on YouTube or wherever you're watching this, and I'll pick up any questions you have from there. If I don't hear anything for a couple of minutes, then I suppose that's it, and you can reach out to me via email or LinkedIn or chat, anything like that, and we can take it from there. One thing that while I'm waiting for question, I forgot to mention what's next. So like I said, as far as FEC is concerned, there's probably going to be a maintenance release soon to handle that resource key security change that Google is doing. And after that, the big new feature we're thinking about is OneDrive attachments. So essentially what we do for Google Drive, and incorporating cloud attachments from Drive, but doing that for OneDrive. So that's probably the next big thing that we have coming up. And as Metaspike in general, the next event is probably going to be the launch of Forensic Email Intelligence. That's our tool for email investigations that's coming up. And we're just putting the final touches on that. So you should expect a similar live event where we will showcase the tool, mention some waitlist perks for any of you guys that have been on our waitlist, and make it available to the public for use, and go from there. So that's what's next. There's a question about RMS decryption and support there. Yes, that's something that's on our radar. I don't know about if it's going to be about FEC or Forensic Email Intelligence first. Possibly for both of them, but I'm inclined to say maybe for Forensic Email Intelligence first, to be able to decrypt RMS and other type of encrypted items. That's on our radar, but thanks for asking. And I think that's about it. So thank you everyone for taking the time to join. This was fun. Like I said, keep an ear out for the Forensic Email Intelligence live workshop coming up soon, and feel free to reach out if any questions come up, or if we can talk about anything. Thanks again, and enjoy your day.